Okay, now welcome students back. So in this part, what we're going to see is one observative question. As I said you, in the previous part 1, we learned the difference between amorphous solid and crystalline solid. Okay. Now we'll do a little bit more about amorphous solid because you have to learn 5% about it as I said you. Okay, 5% we need to learn about it. So we saw the difference between amorphous solid and crystalline solid. Now let us do one question related to amorphous solid. And one of the example of amorphous solid I gave you was glass. An amorphous solid is also known by the name pseudo-solid or supercooled liquid. In old bungalow, window panes are thicker at the bottom and thinner at the top. Old bungalow means which is being built 100 years ago or 50 years ago. If you check the window panes which is made up of glass, okay, and you know that glass is a supercooled liquid, okay. So since it is being a liquid, suppose this is the window pane made up of glass. So and glass, inside glass there are particles and it is a supercooled liquid and liquid always flows, you know. So in old bungalows, if you when you buy a new glass and fix it up in that particular bungalow long time back, the thickness all around will be equal. But when you fix it in the window pane, now it becomes vertical. So glass being a supercooled liquid, so as the time passes in old bungalow, the particle of glass flows down, obeying the law of gravity. All the particles which is at the top will flow down obeying the law of gravity and accumulates at the bottom. Okay, whereby today if you take it out the window panes of that particular bungalow and check, the bottom portion will be thicker and the top portion will be thinner. And this question was asked in CBSE. Okay, so why in old bungalow the window panes are thicker at the bottom and thinner at the top? So you have to say like this: glass is a supercooled liquid, so the particle of glass flows down as the time passes owing the law of gravity and accumulates at the bottom, whereby the bottom portion becomes thicker and the top portion becomes thinner. So this is much we have to learn about 5% about amorphous solid. Now onwards we will learn 95% only about crystalline solid. So we have already seen the difference between amorphous and crystalline solid. Now we will see type of crystalline solid, students. So there are 4 types of crystalline solid: molecular solid, ionic solid, covalent solid and metallic solid. And you know that all solids are composed of particles, maybe ion, atom or molecule. So first let us see, in molecular solid the particles are held together by which force? Similarly in ionic, covalent and metallic solid, and I'll give you the example of that. So do remember, in molecular solids the particles are held together by hydrogen bond and van der Waals bond. Both are weak bonds. Hydrogen bond is also weak, but this is the weakest bond. Van der Waals bond is the weakest and hydrogen is a weak bond. So in molecular solid the particles are held together by either hydrogen bond or by weak van der Waals force. Okay, and one of the example of molecular solid is dry ice. And dry ice means solid carbon dioxide. So solid carbon dioxide, which is also called dry ice, is one of the example of molecular solid where the particles are held together by hydrogen bond and van der Waals force. Next is your ionic solid. Do remember, ionic solid are held together by ionic bond, that is electrovalent bond. I repeat again, ionic solid are held together by ionic bond, also known by the name electrovalent bond, but more precisely we call electrostatic force of attraction. So do remember, in ionic solid the particles are held together by electrostatic force of attraction. And one of the example of ionic solid is sodium chloride, that is NaCl. Covalent solid are held inside covalent solid, the particles are held together by covalent bond. And the example of covalent solid is diamond and graphite. Okay. Since covalent solid structure looks like a network structure, therefore covalent solid is also called network solid. So there is another name for covalent solid. Covalent solid is also called network solid. And the last one is metallic solid. Inside metallic solid the particles are held together by metallic bond, and one of the example of metallic solid is copper. So do remember, student, there are 4 types of crystalline solids: molecular, ionic, covalent and your metallic solid, in which covalent solid example is diamond graphite. The particles are held together by covalent bond, and if you see their structure, it looks like network. Therefore, we call it by the name network solid to the covalent solid. Okay. Now let us see the syllabus. In your syllabus, you don't have to learn about molecular solid. In CBSE board, they learn about molecular solid, where they learn about polar molecular solid, non-polar molecular solid, and hydrogen bond molecular solid. But right now, it is not in the syllabus. Just remember the force present in the molecular solid and the example of it as dry ice, like solid carbon dioxide. Rest 3 is in your syllabus. So this is in your syllabus. So we need inside ionic solid we need to learn is about NaCl structure. In covalent solid we need to learn is about diamond and graphite structure. In metallic solid we need to learn is about copper. So far we have finished is that in part 1 I did the difference. I showed you the syllabus of solid state. Then we saw the difference between amorphous and crystalline solid, and in this part I have taught you one observative reasoning questions regarding amorphous solid and what are the types of crystalline solid and which is in our syllabus. Thank you very much.